Hi, everyone. Charlie gave me a really awesome task predicting the future of research, and that's something I can't do. I think that's for a lot of really smart people who live in the academic world to come up with new ideas and decide what they're going to do about that. So I decided probably the best way to do this would be talk about the obvious. The obvious is always, what I'm going to talk about is, I assume you can see my slides. Michelle is broadcasting them, and Michelle, I have control over them now?
Yep, you're good.
Okay. I wanted to talk about digital transformation and exactly what that is. You know, we talk about it all the time. The future of everything we do, whether it's in imaging, radiation, oncology, medicine, walking down the street, getting on a bus, taking an Uber or whatever we do, all involves today something called digital transformation. And I wanted to start by just talking about it. Let's see. It's not moving forward, so I think you're...
there you go.
Excuse me?
You can press enter.
Press enter. No.
Okay.
So, so all of this gives us a headache. At least gives me a headache. What does all this mean, and what is the future of medicine and the intersection of diagnosis, treatment, and technology mean to us? I guess next slide. So digital transformation, doesn't simply mean using digital tools. We've all adapted ourselves. Just looking at Tom's presentation, Steve's comments, we've gone from a time when we held paper and pen in our hands and we held images on x-rays to where everything is done using digital tools. But that's simply using a digital tool to mimic and perform tasks that we're used to doing. Digital transformation involves innovation, how we are going to solve problems using digital tools that have not yet been invented to make either the process easier, quicker, or more impactful, whether it's providing more bang for your buck, or whether it's providing things that we never thought of. That's really what digital transformation is all about. Next. So, the other term that we have to think about is artificial intelligence. And, again, this is all stuff we know about and we hear about, but I'm setting the plate. Artificial intelligence is simply giving machines the ability to appear as if they have human intelligence. In other words, how do we create algorithms that act and quote unquote think, or maybe copy the way a human brain can look at something? The next slide. And as we all know, the human brain is very complex. It's full of this bunch of neural networks that really can't be recreated, but we try to mimic, and that is artificial intelligence. The next terminology that we use is deep machine learning. And deep machine learning is simply the fact that we now are able to take computational devices and attach them to each other in such a way that we can do many processes in microseconds and use these algorithms and this artificial intelligence and train the machine to learn. And I'm going to stop for a second. And by training the machine to learn, it used to be that we created algorithms and using artificial intelligence, we were able to come up with answers. The new generation of artificial intelligence and deep machine learning is that the computer itself can come up with the algorithm. So if the task is, we want to see if we can take a CT and find out where there is blood on the CT as an interpretation of the data. It used to be that an algorithm had to be created. Now we're able to give the task to the computers using deep machine learning, and they will take that task and do the interpretation of that task and create algorithms, many algorithms, continue to test them until using the testing data set, we have an algorithm that we believe can actually do that using the data. Next slide. I stole this slide from a presentation that Mike Tilkin did a number of years ago, and I have it hanging on my wall in my living room because I use it to show my children all the time. And the point of this was, if you put my picture in there, that using deep machine learning, it'll say I'm human, and they don't believe it. So now I have something that's this is my version of alternative facts. But it's how deep machine learning actually works and processes. There was a paper that was presented at the RSNA this year, which I think it was from Yale University, where they looked at liver lesions using algorithms of using artificial intelligence and machine learning to train these algorithms. Yes, and then they introduced music into the algorithm, and what they discovered, not only that they could create an algorithm that could look at liver lesions and determine pathology from the algorithms of the images, but they were able to actually present how the machine got to where they were able to make the interpretation, which was really shocking, because we assume that a machine looks at an image, and then that machine looking at the image uses an algorithm or the same way our brain works to come up with the conclusion. But what we've learned, and makes logical sense, is a machine doesn't look at an image. A machine looks at zeros and ones. It looks at digital information. So the image is created for the human, the radiologist, or the radiation oncologist doing, QA or whatever. That image is created for our eyes. But the machine doesn't need an image. The machine just looks at zeros and ones. And now we're learning that the machine can come up with conclusions and do an analysis and interpretation that we can't do, that only a machine can do, which is kind of frightening. And we'll get to the frightening part at the very end. Next slide. So artificial intelligence, I participated in a webinar. I think I've showed you this slide maybe a year or two ago, but it always sticks with me. They were talking about how artificial intelligence is being used in everyday life, and the examples they gave were Facebook, and we've heard a lot about Facebook now and how they use their artificial intelligence and digital transformations. Netflix, and anybody who uses Netflix, it's always amazing how they can tell you what movie or show you're going to like, and you usually do. Certainly driverless or autonomous cars. And the fourth example they gave was radiology, as if we're already using it, and it's being applied to everything we do in radiology. This wasn't a matter of predicting the future. To them, this was the way things actually are. Next slide. And here's just examples of things. And I like that picture of the driverless car. That's a concept car. There was at the auto show recently. What's interesting about that picture to me is there is no steering wheel. Most of the pictures they show have a steering wheel to make us feel better, but there is no steering wheel there. And this is how artificial intelligence is going to be able to transport us. And certainly we talked about the things we know, Spotify or Facebook. And then on the bottom right, anybody who's watched enough TV, as I've had the occasion to do in the last 9 months, we'll see an ad, and I think this is a Dell ad, where they're showing cows, and that beam going out of the cow's head is actually going to a satellite. And they're talking about how we can now predict milk and milk our cows and use artificial intelligence and machine learning to decide how a cow is going to be milked. So one thing they don't talk about is whether intelligence has done the cow's brain yet. But I think that this is really representative of what the future means in terms of all that we do. Next. I took this from an article that was recently published, and the article is about the use of artificial intelligence in radiation oncology. So talking about whether this will actually be practical to what we're doing in the future at the ACR, they were talking about whether you could take a CT and using an algorithm make an MR image out of it and vice versa. Whether you could take a CT or MR image and you can, instead of giving the patient contrast, having such a large data set that's been trained, one can actually apply the features that are seen on in the studies themselves, the zeros and ones in the images, that you can predict what the contrast might look like. You'll be able to derive tumor histories without doing a biopsy, so that's a virtual biopsies. Identifying the toxicity risk to patients based on their individual characteristics. In other words, radiation oncologists will be able to have all the information of a patient in one place, and individually, like personalized medicine, you'll have personalized treatments. Next slide. Again, this is just more of the same. Will you be able to do remote treatment planning, without having to be present when it's done? And of course, the last one, which is of great interest, is will we be able to predict outcomes in patients over long-term periods before they've even started their treatments, just knowing the individual personalized and precision medicine treatments that we can do. Next slide. At the RSNA this year, I was not there, but I'm sure Bill was, and those who were there can tell you that, artificial intelligence was everywhere. I did get a copy. The RSNA now has a journal or an online journal called the Artificial Intelligence Insider. And what you see there is a list of 75 sightings and publications and articles and things that they published about artificial intelligence just from the RSNA. And if you look at the next slide, what I found of interest was the different areas that they were producing it in, the largest of which was in software development, but things that we deal with like breast, TBI in our Head Injury Institute, cancer detection, certainly workflow and equipment were the ones that seem to appear the most. So as we look to the future of the type of research we're going to be doing, artificial intelligence and these kind of processes will absolutely affect what we do. I made a point here of not talking specifically about the ACR and the DSI and all the things we're doing, because I'm sure you all know about those, but this is why it's all important, because 20 years from now when we do research, it's going to be very different. And if you look at all the things, I just took the top 6 things that came to my head that we have to do in clinical trials, and every single one of these will be affected by artificial intelligence. I can already tell you that the accrual of subjects into trials, there are multiple companies that have developed AI and ML, machine learning processes, to look at the EHR and search all that graveyard of data that exists in there to allow either clinical trials done for NIH or for industry to find the right patients based on their personalized profiles. Where the hardest thing, the gold doubloon of any clinical trial, if you ask someone who, Etta, I'm sure I can, refer, I know you're in the back there, the gold doubloon of clinical trials is enrolling subjects and finding subjects. We now have a way where we can use these algorithms in AI to search for accrual. Regulatory, one of the biggest headaches we have in clinical trials. Just the other day, someone demoed for me a tool set that is available to anyone who's going to be participating in clinical trials that has all the regulatory requirements for clinical trials baked into it, but also has algorithms. So it's almost like edit checks on steroids, meaning that it's able to look in real time through CTMS data and other data and make sure that all the I's are dotted and the T's are crossed that are necessary for QA/QC regulatory and data management. So that's how it will apply not only to the research being done, but to the way we do all our work in the office. Next slide. So I'm going to give you my view of what the world might look like in medicine in 10 years. You're lying at home, you had a tough weekend, you're really not feeling well, and you think you're sick. So next slide. So what do? Well, in the future, you pick up your personalized computer, your phone, and you start to enter data into it. And this data goes to somewhere. doesn't go to your local physician. It may go to your insurance company. Right now, there are several insurance companies in Europe that work this way. Your first contact with any medical provider is through information put into your phone, and they then triage that information. And again, using huge data sets, I think Ed is going to talk about data, huge data sets, the information you put in your phone will not only go to a central data center that has all your data, your entire health record, all your diagnostics and everything, and using a triage center and using decision support, something else the ACR has been a trailblazer in, where someone will, using an expertise that exists, insurance information, where you are, your location, and your location will make a decision. In some cases, it'll actually just tell you what to do and will call you back or contact you at a later date to see how you're doing to add more advice without you ever having to speak to anyone. Or in some cases, it may want you to speak to a provider, but in many cases, it'll make a decision that you need some sort of diagnostic testing. And what does that mean? Diagnostic testing may be an imaging study, maybe a cardiac study, maybe an ophthalmologic study, maybe a pathologic study, maybe a blood test of some sort or a marker test or something, but it'll be a diagnostic determination. And that central triage center, which is really just large supercomputers, will check the availability in your neighborhood or in your area for what you need done, and a self-driving car will pop up in front of your house 5 seconds later. And you'll get into that car and it'll take you somewhere. Next slide. And that somewhere is a diagnostic center where the scheduling has been centrally controlled. As I said, the decision support is controlled. And then some sort of equipment, let's say you're having an imaging test. That equipment, and this is already true of new generation scanners, will have a black box that connects it sort of like that cow was connected up into space to a satellite, which will then go to another center which will have your information, and it'll have your weight, your height, all your previous history, and it'll automatically protocol your study based on that. And it'll also decide whether you need contrast, or, as we talked about earlier, maybe you will just have a study where the contrast will be applied to your study based on other characteristics of either yourself or your study. Next slide. So now we have a bunch of information. So what do we do with these studies? Well, are they going to be interpreted locally, or can it go anywhere? Several years ago, it's a while ago, in a discussion with Quintiles, which is the largest CRO in the world, they were thinking about having computing centers located all around the world that could bring in all the imaging done at any center and then process and store them and make them available to who needed them, which is really quite a concept. So you go to have your study done at Jefferson or Penn, and when it's done, it just leaves. There's no one there that even touches it. It goes to a central place, and then the decision is made who's going to do the interpretation. And I'm sure that interpretation would be decided by a combination of factors of expertise, experience, and cost. And I put on the ACR AI data tools. In the middle, we have ACR Connect, which is for the movement of images. But if you look at the next slide, this was a slide that was shown to the board, I don't know, Bill, maybe 30, 40 years ago, the first time we saw this slide. And I'm sure we've all seen it. Gives me a headache. I can't really, but every little process on this slide is somewhere where the ACR has gone through a digital transformation to assist in the movement, the interpretation, all the processes in imaging, and eventually every one of those boxes will be filled in using some sort of machine learning or AI tool. And we'll stop there, just to show that the ACR has been ahead of this curve for as long as it's we've known about it. Next slide. So then what happens? What happens is somebody has to come up with a diagnosis. We're very used to interpretation where someone looks at a picture and gives an opinion. I think using digital data, it's more likely we should call this analysis. So whether it's using artificial intelligence to look at lesions or find blood in the brain, or work with the one go to the top of the work list, that's really the type of things we're seeing now. But the field of radiomics, in which you can look at data from an image and take a kidney mass, which has 70 different things a radiologist might say about it, but a machine using the zeros and ones in that data can process those 70 things and then look at that mass compared to genomic information, pathologic information, prior biopsies information, and then come up with a precision medicine, a way of getting a genomic signature and a precision signature so that in future treatments can be related to what's found. Also, the future of the virtual biopsy, will it be possible just by having images, or I should say the data of the imaging study sent to a data center and then the computational work done, will they actually be able to come up with what the tissue will look like, and therefore it'll be a virtual biopsy that's done based on the imaging data alone. Next slide. And certainly treatment decisions. This is already happening. Every pharmaceutical company, biotech company is starting to come up with ways that they can use data available on a personalized and precision basis to use for treatment. As we talked about earlier, it'll happen in radiation oncology. Eventually it'll happen where there are now surgical robots. They're used for many things, but we'll have biopsy robots and other surgical robots, and they'll all be controlled for this. And finally, I don't mean to bring it down to its basest level, but health services research and outcomes research, as long as we're able to collect the data and put the data in the right place, we'll be able to really, we'll know, rather than predicting what we think we've done, which we've done a pretty good job of, we'll now have such exhaustive data, we'll be able to actually come up with outcomes that are meaningful and are helpful. Again, every step of that process that I just mentioned, being researchers will have to be involved in and have to work in. By the way, I'm trying to do this as quickly as I can because, as Tom said, lunch is like in 4 minutes? So I'll try to do that. Try to be quicker. So I just want to end with, this is the chilling thought. There's something called technical singularity. And what it really is talking about is a computer's ability to do a human computation. When does one computer become equal to what one brain can output? And the original prediction for that was made was 2029. That's only, that's 11 years from now, that a computer will exist that can do the same computational abilities as a human brain, and it'll cost $1,000. That's the prediction. But the real scary prediction, in 2045, there'll be a crossover where the intelligence created using computational abilities will be equal to the computational ability of 1 billion brains. I know I sound like the guy from Austin Powers. 1 billion brains, but and that'll cost $1,000. So the real question is, and it's many of you will be there in 2045 and see if this is true. But that's where things like the Terminator and Skynet come from. When will the computer actually, be able to perform equal to the human brain? And my last slide, which I think will be self-explanatory, is all of this, every last bit of it, is dependent on big data, and really, really big data. In other words, we probably will be giving up some of our privacy and our personal data to accomplish this, but in order to really do precision medicine of the future, all our data, all our DNA, I recently had some genetic testing. It's amazing, all that data will be big data and in one place, and not only will it be used selfishly for our own personal medical treatment, but that data can be used to train using artificial intelligence and machine learning and algorithms that are developed. It can all be used to train and learn more about things that will help all our subjects and patients. And I'm going to stop there because I'm probably already over time.